Hello again. So I was going to continue the CHIP8 interpreter and the frame buffer, but I realized that there were a lot of problems that I introduced. So this is going to be more of a little bit of house cleaning so I can continue working on the frame buffer. So if I go to the CHIP8 here, and so if I do a build here, and then I run, we had nothing from last time. There were a few mistakes of why nothing was showing on the screen, so we're going to go ahead and we're going to fix those. So if I do, so if we go back to the CHIP8 here, there are, well, there are quite a bit of problems here. So the first one, though, is that the whole setup of the window doesn't really. I have a couple refreshes here, and I'm actually not even using the box in the regular, so, excuse me, there's no reason to refresh that part of the window. So there are, one thing I really forgot to do here is, I forgot to do the start color once I, I didn't start the color there, so that's why that wasn't working. If I do another build here, now the color works. It's not the right color, but it's the color. I actually went through and I made some notes of all the mistakes I had because when I was watching back the videos, I was like, "Oh, that looks terrible." It's interesting because when you watch yourself code back, you watch yourself make the mistakes and you don't realize it while coding. So I'm going back here and I'm fixing these up. So the first one that I want to do here is we have no echo here. One thing to do here though is we have to do init foreign curses there, and then we also need to do a curse set is false. This actually makes it so that the cursor isn't showing in end curses, which it makes it just look better. We also don't need these two refreshes here, and then I'm refreshing way too many times. If I actually go down to draw buffer, I should be able to just do one refresh there. So let's do a build. Okay, cool. I don't have the message showing anymore, but we don't really need it to show at this time. But that's why the colors weren't showing at all at the end of the last video. So we're in it, we have no echo, and then we also have the no delay on. Okay. Also too, we can also clear the screen here every time, so that basically whenever we go back through our frame buffer to draw it, we're basically starting on a fresh slate, which actually sort of brings me to this other point I had about the frame buffer, which is that the actual frame buffer itself, I'm using a malloc here, but since everything on the frame buffer I'm starting at 0, it'd probably be better if I just did a calloc call. So this would be the, let's look actually, yeah, the total frame buffer size. So if I go over here and do, I actually think those were one word, yeah. So make build, everything compiles, cool. So make sure I don't have any dangling spaces here, so we get add buffer C. And it's just because calloc will automatically make it all 0. It'll allocate everything and initialize it to 0, which is nice for us. So that's cool. What else is I needed to do? Oh, there's a problem on the stack. If I go over here to stack, okay. So what we're doing is we're popping first, and then we're popping whatever's there, and then decrementing. We want decrement, and then pop it. So stack sp minus minus, and then that way we're actually popping the correct value. Because when I was running a test program, I realized that the return was wrong, and I was like, well, there must be something wrong with my stack. And sure enough, it was because it was popping the wrong return address. So that was the fix for that. So add stack C. We're gonna fixed fix the pop function on the stack. Cool. Oh, okay. So also, if we go over to the CPU, this was a really big one, and it took me a long time to hunt this down. This is accidentally, it's saying if the register is 6, set register 1. That's obviously wrong. So that needed to be fixed, and I did it in both these places. So that's a quick bug, just squashed. Yeah, that's a quick bug fixed. Okay, so let's add CPU. Fix register v6 to fix register v6 in the get and set functions. Yeah, and then what have I made here so far? That's why I always check that. CHIP8. Wait, was it clear? Yeah, it was clear. So, yeah. Okay. So we're gonna check that again. So I removed all that stuff. Great. Okay. Fixed regular mode and curses display. Add a color output. Oops. I also want to make this bigger. Cool. So those are all good. And then if we do build, perfect. Nothing should really be happening right now, so that's all fine. There were other things to be done here. The draw function, actually. This is one way to do it. I'm actually not really happy about that. Also, this is completely wrong. I'm turning on the pixel and off this attribute for the pixel off, but really I'm trying to turn the pixel on attribute off. So I think a cleaner way to do this would be for, and then while y is less than the frame height, and then x is 0, x is less than frame width, and then we'll add y, or no, we're going to add x, I'm sorry. So this is fine and it's linear, but because it's all just one continuous array, but I think it's clear if we're kind of we're stepping through column by column. So what I want to do here is I want to say if CPU frame buffer x plus, and then we need to calculate y here, so that's the frame width. And then we want to see if it's set to 1. if it's set to 1, then we want to do this, where we basically do the on color and we add it. Else we want to do it for the off color. Pixel off, pixel off. Yeah. Cool, still compiles. I just think it's cleaner. We're not really even doing anything. We'll get to it, but the draw function on here is, that's very wrong. We'll get to that. I might do that. I might actually start part 2 with that. We'll fix that up later. Right now, let's see. Oh, another one of the big mistakes I made. This actually took me forever to debug because I was looking at it and I realized here. Actually, I'll just show you the problem. So if I do make, if I run in debug, well here. So if I do make file here, we can see that when I'm running it, it's running test CH8. So this is the program that's running. The problem is that if I do a debug, you'll notice, and I did this initially for testing, but you'll notice that the instruction register is just whatever op is there. So there are reasons why 0 shows there. That's because that's where the instruction, A is actually the load instruction. Load is basically load this value. So A is basically saying load this value into the I register, so for the index register. And so 224 is being loaded into the index register. So there it's actually correct. But basically you can see that we're always putting that, we're always putting whatever the opcode is in the index register. That's wrong. I initially did that so I could test to make sure that it was working because I had that debug output and I just wanted to make sure, and it led to a bug way later when I was working on this. So what we want to do here is we don't want to set the op that's fetched from the CPU and put it on I. We actually just want to do, I believe that's an unsigned, so we'll do opcode is, if I can spell, CPU, and then here we're just going to basically say opcode. Cool. And then we're going to do the same thing down here. Yeah, right here. So let's do debug again. Now the index register will only work. So here we loaded, because remember, the A instruction is, or the hex value of A is for load. So it was load 224 into the index register, which is exactly what's happening there. So that's working fine. And then there's actually no more loads in this program. But essentially, we only want to load the index register when we're telling it to. So that's great. So that's another bug squashed. We kind of did 2 here. That's okay. So what we did here is we fixed the opcode to not be written to the index register. Additionally, we fixed the draw buffer function on CHIP8. Great. So that was a major bug that led to a lot of problems later on. Let's close that. We don't need that. Okay. Some other bugs that I noticed is that they have to actually do with the let's see. Every time something's fetched, it doesn't automatically increment the program counter. That's a mistake. Really, it should happen depending on what's being called. There are only a couple of instructions that don't actually do this, where it increments the program counter. And actually, that's the wrong place. We need to do on the execute. If you clear the screen, you increment the program counter. When you return, you increment the program counter. When you jump to a specific address, you do not increment the program counter. The same thing with the call address, because both anything that has to do where you're jumping or calling, you don't want to increment the program counter because you're jumping there to start executing there. So that was a bug that was happening where basically it was executing way down the road, or it was executing after one of these calls, and that's not correct. So it really needs to be added in every other place but these two, and there's one more down here. It's another jump. So here, we're skipping the next instruction if it's like, for these, for example, we're skipping the next instruction if the value in Vx is equal to the comparison value, then we increment the instruction pointer, or the program counter, and then we do it again. So same thing down here. So in some places you're actually incrementing it twice depending on how the how it's evaluated when the instruction is executed. So yep, we're going to do that one there. What's the next one? Oops. Yep, you do for or. You do for and. The XOR, add, sub Vx by, shift right, sub not, borrow, shift left, not equal. Oh, if you're loading, okay, so this is the one we also don't want. If you're loading a specific address, like the one that we were demonstrating back there for the instruction for the opcode A224, where basically we're loading 224 into the index register. We don't want to increment the program counter in that case. Or do we? No, we do. We absolutely do in that case. Otherwise, it's just going to sit on that same instruction and not increment. Here in this jump, okay, yeah, it's in the jump and the calls. What am I thinking? No, yeah, so this, of course, increments the program counter, but if you're jumping to V0, if you're jumping to, well, let's see, what does this do? Gets the register at V0, gets the address there. Oh, it adds V0 to the address and sets the program counter to it. So in this instruction where it's setting the program counter to something specific, we don't want to increment the program counter there because, well, that's the whole point of the instruction, is to change the program counter, so we don't want to increment it further. We'll come back to that. There's a lot wrong with that. One major thing being that you're supposed to set the V0 or the VF flag if there's a collision. I'm not doing that check at all. And they're actually XOR'd into place. We'll come back to that. I'll do that in part 2. So skip, load, increment, add, yeah, that's fine. So let's look. Oops. Diff CPU C. Yeah. So we're just adding the program counter in these certain places. Cool. So we'll do a fixed incrementing the PC register on fixed incrementing the PC register on the appropriate instructions. Yeah, because there were 3 that don't need it, which is the jump on the calls. Okay, great. That's been fixed. Actually, when we do the decode, there are some problems here. One is, so this is actually a really small one, but it did lead to a bug. Here is where the these addresses, I was only getting, the old one was basically, it was just, first of all, this would never get anything because it would just be 0, because the very first, the very first nibble will never be 1 here. It's always going to be 2. And also, we want to skip the first one and just get the last 3 for the address. So, fixed address I always forget how to spell retrieval. Retrieval. IAL. Fixed address retrieval in JP8ER and call address. Cool. Alright, so that was one problem. Okay. I've only done this in this address, and that was because this is when I was testing it. When I very first started doing the opcodes and I was decoding them, I realized, because the first one I tested was add, it just seemed like the natural place to start. So what I did here was basically, I'm getting the address, or I'm getting the value, because so add is basically add into VX this byte, KK. And so when I get the address, that's fine, because I'm just getting the last byte of the entire opcode. However, the second nibble, or the lower half of the upper byte, I was grabbing it like this, but then you have to shift it over 8 bits, which is just 2 nibbles. So I've done that only for the add address, but it needs to be added for every other case where the nibble is not in the least significant bytes or bits. So what I need to do here is I need to go through and do that. So for example, this 3xkk, I'm getting the second nibble, but it's not being shifted over. So I need to shift over 2 nibbles here. And then here I'm doing the same thing, shift 2 nibbles. Shift 2 nibbles, and then here, because the last nibble here is always going to be 0, 2 nibbles. Actually, that should always be 0. Yeah, we fixed that opcode. Yeah, the opcode was wrong. Again, here we're going to do 2 nibbles to shift over. That's the least significant there, so that's cool. That's the add one. That one was already correct. 8s are easy because it's all in one place. Is that what I called it? I want to say it's on CHIP8.h. 2 nibbles, 1 nibble. Yeah. Okay. So here we're going to do 2 nibbles, and here we're going to do 1 nibble. That's fine. That's fine. 2 nibbles. That's corrected. It's part of why the frame buffer was always wrong. So here we're going to shift 2 nibbles, and then here we're going to shift 1 nibble, and yep. Oop, 2 nibbles here. And another 2 nibbles. So we fixed that opcode. We shifted everything over the 2 nibbles correctly, 2 or 1 nibbles depending on its placement. So commit fixed. How would we even express that? We fixed the opcode value play when building the instruction. Cool. Actually, there's one more. It was somewhere in the F's. There's one more instruction that I realized was off too. That's right. That's correct. F15, F18, FF1E, FF29, FF33, FF55. I clearly copied this from this one. So, FF65. Fixed LDVXI instruction. We'll say decode instruction. Let's actually make sure this. Yep. Cool. And then run. Very cool. Okay. Still builds just fine. I kind of went through and I noticed all these problems and then I fixed them, but I'm just kind of fixing them here because I wanted to continue on making part 2, but I realized there were so many issues I had to address beforehand. That's pretty much all I can think of. Actually, I think over here, this is waiting for some input. Oops. So if I do, I think that last video that was up. Yeah, that was the last video I made. If I do maybe end curses, get character. I remember there being something on getting a character. End curses, get character, non-blocking. I could have swore I used something like W or something like that. I don't know if that actually compiles. That does. Okay. It was waiting each time when going through to get my character input. That's an error, though. Let me just comment these out. Okay. I actually don't really, we don't need these. We will fill it in. I'll keep the comments in there for now. I'll eventually clear those up. There's more work to be done here in the draw buffer, but I'll fix that in part 2 of the frame buffer. And then finally, the other thing I wanted to do, let me look at my notes. Oh, that was one thing too, is I didn't know this. I was initially going to, here, if I go over to CHIP8.h, I was going to use time here to do a sleep. Sleep's not even on time, actually. I was going to do that, but CHIP8.c. Instead, what I'm actually going to do is I'm just going to put a ncurses sleep before the refresh. So if I do use sleep 50,000, that's not an ncurses one. Let me do this is just to control the clock speed, so it's not just flashing on the screen as fast as humanly possible. Yeah. Okay. I'm actually pretty satisfied with this. I went through and we cleaned up a lot of things. Let me just double check my notes here. Everything. We did this. We did the fetching. The biggest bug that I had was this, where basically I was fetching and resetting the index register on the CPU, which just, it led to so many bugs and I just could not figure it out. And of course I just did that to debug it at first, just to put in a register to make sure I was fetching them properly, but forgot about it. And so that's what I got. Yeah, the only other thing actually, if I go over here on the CPU, let's take a look at the CHIP8 here. Yeah, right here, these two registers, so LDIVX and LDVXI. We'll go over here on the LDIVX and LDVXI. It says here that after it fills those memories, after it fills the memory values, or after it fills the registers with the values from memory, or it fills the memory with the registers, I is then set to I plus X plus 1. I'm not doing that, I'm just doing this. So what we want to do is I is equal to I plus R plus 1, because here is whatever the value of our register is. Oops, plus 1. Yeah. Cool, that still works. And then, okay, so what do we do on CHIP8? Added, first thing we did was we made it so that, changed get ch to wget ch to not block. Be non-blocking. Additionally, too, is set the refresh rate. We'll just do that. And then over here, CPU commit. We basically fixed LD VX VI and LDI VX to ferment. Yep. And then git diff includes CHIP8. To sleep. To add sleep. Push origin master. Perfect. Okay, great. Thank you so much for watching. I'll eventually, now that kind of a lot of these tiny bugs are sorted out that were kind of preventing me from finishing the frame buffer because it just led to all these bugs, I'll finally be able to come back and finish the frame buffer. So thanks a lot for watching.